All right, we're going to look at square roots and cube roots and how to simplify them, okay? So the first thing I'm going to do here is, well, let me go ahead and write it down and show you what it's asking me to do, and then I have a very easier way to do this in Desmos. So when I'm simplifying this, I need to look for perfect cubes in here. What are some perfect cubes? For example, 2 cubed is a perfect, well, 8 is a perfect cube right here because 8 square root of 8 is 2. 27 is a perfect cube because it's cube root. I said square root. Cube root of 27 is 3 because 3 cubed is 27. 3 times 3 times 3 is 27. And then 64, and then so on, okay? And then what I do with this is I would take my perfect cubes, any one of these, okay? And then I would see which one would go into this and then take it out. That's a lot of work. I can do it, but I wanted to show you a much easier way you can do that in Desmos. So what I'm going to do here is I'm going to leave the stuff on the outside alone. Just leave that negative there. But the 128, what I'm going to do is, because it's a cube root, I'm going to take 128 and divide it by x to the x cubed. Turn this into a table. And then I'm going to go ahead and press and click on 2 that's the last number that it gives you. Press enter until you get to these zeros and then go up. And these will be my numbers. This is going to be the number on the outside, so negative 4, I should say. So this is I'm going to keep the negative on the outside, and then you have 4 cube root of, let's see what it does must say, 2. Again, the negative is just out there, hanging out, and I'll keep it on the outside, and then the 4 comes from simplifying it. So I'm going to put negative 4 here, and then positive 2 here, okay? And then after you do all that work, if you want to go ahead and check your answers to see if they're equivalent, you can do that. So 3 cube root, whoops, cube root, what was that? Cube root of 128, and then my answer was negative 4 cube root. Oh, my bad, hold on. Cube root of 4. See how they have the same thing? So I know that this is equivalent. All right, this one. When I am, hold on, let me copy it down over real quick. So when I'm adding or subtracting radical expressions, I can only put the same radicals together, meaning they have to have the same radical, square root, or cube root, and then they also have to have the same number underneath as well, okay? So what I'm going to do here is I'm going to go ahead and simplify each one of these. I can do it, just using math. For example, this is 4, not math, but just using this 4 times 5, and so this would be 2 square root of 5. Or I'm going to go ahead and do this part in Desmos, y'all, because there's so many of them I have to simplify. So I'm going to do here 20 divided by x squared, and then turn this into a table of values, and then just press enter. And so yeah, 2, 5. So this is going to be 2 square root of 5 minus, this will be 2 square root of 2, I think. Let's see. I'll go ahead and, I'm just going to take that out. I'm just going to change the numbers in the table here. So this is going to be 8. So this is, let's see. Okay. So this one is going to be 2 square root of 2 for square root of 8. This one is going to be 3 square root of 5, I believe. Let's see. Just keep pressing enter until you get to the zeros. So this is 3 square root of 5. And this one is going to be, let's say, 5 square root of I'm just having technical difficulties on here. I think I'm trying to do these too fast. 50, and so yeah, 5 square root of 2. So this one's going to be 5 square root of 2. Now that I've simplified all of them, we can only put the like radicals together. So what that means is square root of 5's go together, and then square root of 2's go together. Okay, so we're just going to combine like terms. So this is going to be 2 minus 3, which is negative 1 square root of 5. Okay, and then negative 2 plus 5 is positive 3 square root of 2. So this is going to negative 1. I can just say that's negative square root of 5 plus 3 square root of 2. All right, that's how you would do that one. And also, well, you can definitely, since it's a multiple choice, if you're just like, I'm not doing all that, that is okay, as long as you know how to plug it in Desmos and then find what is equivalent. Okay, so square root of 20 minus square root of 8 minus square root of 45 plus square root of 50, and then my answer choice that I picked was 5 plus 3 square root of 2. They are equivalent. I probably should have started with just plugging it in Desmos instead of spending, what was it, like 4 minutes on this? Anyhow, that's what that is. This one, I need to go ahead and do it by hand because, well, I don't have multiple choice here. But anyway, the first thing I need to do is combine the numbers on the outside. So I need to do 4 times negative 6 here, which is negative 24. So negative 24 will be the number on the outside here, negative 24. And then the number on the inside, I have to do 3 times 18, which is 3 times 18, which is 54. And then I need to go ahead and simplify 54 here, okay? So I need to do, I'll do that part in Desmos. So I'm going to do here 54 divided by x cubed, because it's a cube root. Turn it into a table of values, scroll down, and then just press enter. So 3, 2. So number on the outside is 3. So I'm going to go ahead and keep this negative 24 here. And then 3 on the outside, cube root of, what was it? I'm looking at these two numbers. And then 2 on the inside. And then here I have negative 24 times 3. Negative 24 times 3, which is negative 72. Cube root of 2. That's what that is. Yeah, let's go ahead and check this answer in Desmos. I want to make sure that we're thorough with this. 4 cube root. I wish there was an easier way to put cube root in Desmos. That times negative 6. Sorry, I'm still trying to figure out how to put this easier in Desmos. That's okay, at least it's calculating for me. That, and the answer that I think it is, well, I know it is. I hope it is. Let's see, 2. Yep, they're equivalent, so I know I did this right. All right, a couple more here. Which radical expression, when expressed in simplified form, is 5 cube root of 3? So I need to go ahead and simplify all of this. All right, so I'm going to do 45 divided by x squared, turn it into a table of values. Boop, boop, boop. So this is going to be 3 square root of 5. That's not what I'm looking for. I'm looking for 5 square root of 3. Let me change this number to 30. This one actually I cannot simplify because it's when I have 1 and 30, that means that I don't really have any perfect squares under there that I can take out. This one is 5, 3. Yep, that one works. All right. And then of course we can just, I guess I could have just started off by just seeing which one is equivalent. For example, like, see how that's not equivalent? That's not equivalent. This one is equivalent. All right. This problem, it says which expression in simplest form of this. Okay, I think I'll save us some trouble and do this in Desmos first and then show you how to do it by hand. Okay, so what I can do in Desmos is since I'm just looking for equivalent, I can go ahead and type it in and just plug in some numbers for R and T and then see which one is equivalent. And then after that, I'll show you how to do this by hand. Okay, 3RT. Well, that wasn't it. And I'm typing this pretty fast, so I better double check. Just give it a quick look and make sure you see it. Well, that's it right there, the second one. Okay. All right, so let's go ahead and do this by hand. So to do this by hand, we're going to go ahead and simplify 108. So square root of 108, I'll put that part in Desmos. So 108 divided by x squared, and then turn it into a table of values, see what perfect square I can take out. So it looks like I can take out 6. So 36 times 3 is 108, so 6 comes out. Whoops, I lost my pen here. Hold on. All right, that took a long time for me to find my pen, but let's see, where was I? 6 and 3. 6 on the outside, and then I'm going to have 3 on the inside. I'll leave some space here. Now, the r to the 5th, the way we simplify that is we're trying to take out as many perfect squares as I can out of here. R to the 5th, I can rewrite this as r squared, and r. 1, 2, 3, 4, 5, right there. Which means that I can take out 2 r's or r squared from here. Okay? A shortcut would be if I did square root of r5 and write it as, like, try to find an even number in it. And I can go ahead and just divide this by 2. So that would be r squared, and then the r gets left over here. Okay, so I forgot to put that. Same thing here, I can take out 8. So 8 divided by 2 is 4. So this would be t to the 4th power, and then I have 1t left, and that's how I got this answer. All right, guys, thank you. So that concludes all of the expressions and operation category on the Algebra 1 SOL.